How do robots manage high-power battery heat? Imagine a robot working tirelessly on a hot day. Its battery generating heat from all that power. How does it stay cool and keep running smoothly? That's what we're about to find out. When robots use high-power batteries, they produce a lot of heat because of the electrical energy flowing through them. Too much heat can cause the battery to degrade faster, or worse, lead to safety hazards like thermal runaway, where the battery gets dangerously hot and can catch fire. So, managing this heat is super important for robot safety and performance. Robots use several smart ways to keep their batteries cool. The first is thermal monitoring. Tiny temperature sensors are embedded in the battery pack. These sensors constantly check how hot the batteries are and send data to a control system called the battery management system. This system then makes decisions, like slowing down the power draw or turning on cooling devices to prevent overheating. Passive cooling is the simplest method. It uses materials and design tricks to dissipate heat naturally. For example, heat sinks made of aluminum or copper are attached to the battery. These materials conduct heat away from the cells. The battery pack might also have fins or ridges that increase surface area, helping airflow naturally around the pack to carry heat away. Sometimes, the battery case itself is made of thermally conductive materials that spread heat evenly, avoiding hot spots. When passive cooling isn't enough, robots turn to active cooling systems. Liquid cooling is very common. Coolant, like water or special oils, circulates through tubes around the batteries. The coolant absorbs heat and carries it to a radiator or heat exchanger, where it is released into the air. Fans can also be used to blow air over the battery or radiator, speeding up heat transfer. In extreme cases, some robots use refrigeration systems with compressors and refrigerants to actively lower battery temperatures, especially in hot environments or when the robot needs to operate for long periods. A battery thermal management system, or BTMS, combines sensors, cooling parts, and control electronics. It keeps the battery temperature within a safe range, usually between 20 and 45 degrees Celsius. In cold weather, it can even warm the batteries with heating elements to make sure they charge and work properly. The battery management system also plays a key role. It reduces charging or discharging rates if the battery gets too hot. It balances the cells to prevent uneven heating, which can cause damage. If temperatures get dangerously high, it can shut down the battery to prevent accidents. Design choices depend on what the robot does and where it operates. Heavy-duty robots with large batteries often use liquid cooling and thick heat sinks made of copper. Smaller, mobile robots prioritize lightweight aluminum heat sinks and air cooling to save weight and power. Engineers use computer models to simulate heat flow and find hotspots before building the actual cooling system. All these methods work together to extend battery life, keep the robot performing reliably, and ensure safety. Managing heat properly means the robot can work longer, handle tough conditions, and stay safe for everyone around it.